All right, hello everybody. Today we're going to do a lab on proof of work. Proof of work isn't a new concept to us at this point. We've talked about it a few times. Remember, this is the concept of where everyone, for example, on the Bitcoin network, every 10 minutes competes to solve this puzzle. And the winner of the person that solves that puzzle gets basically free Bitcoin, i.e. They successfully mine for some Bitcoin. And this is important because this is the process that helps secure the Bitcoin network and also processes all the transactions. So in essence, this is the actual fuel that makes the Bitcoin network run. So for that reason, we're going to spend a pretty good amount of time just going through how this works, and we'll do that in 3 parts. And each part will sort of build on the next part. The first part is going to be a rehash of a, no pun intended, of a lab that we did early in the semester, and that was on secure hashing. So let's get started there, and as we sort of build this lab, we'll see how it slowly evolves into a proof of work algorithm. So let's log into our AWS server that we have. Remember, that's an SSH command. We -I, and then we point it to the Bitcoin key that we have. It's probably still in your downloads directory on your computer. And then we say Ubuntu, which is the username, at the IP address. And great, we're logged in. Let's see here. Good, all of our old folders are still there. I'm gonna log into mine. And I created a folder called proof of work. So I'm just gonna log in there. It's empty, good. And I'm gonna create a file called POW for proof of work 1.py. That's going to be 1 of 3. So the next file we'll do is 2 and 3. All right. So first thing I have to do, remember we have to import some libraries. We want to use sys will help us get arguments off of the command line. So we're going to pass a message to this program, and sys will help us retrieve that message. We're also going to use the hash library, and we're going to use the Base64 library. And what is Base64? Well, Base64 is a way of representing numbers. So the numbers we use every day are base 10 numbers, which means we use the numbers 0 through 9, and then we sort of start again at 10 and go up to 19, and then we switch every 10 numbers. Base64 is the same concept, except it switches every 64 numbers. And why are we using Base64? Well, it's just a very concise way of representing a number. For example, a binary number, which is a base 2 number, just has 0 and 1. So to represent numbers, it takes a long time or it takes a long string to represent, for example, the number 1,000 in zeros and ones. So we're using Base64 just to give ourselves a shorter, more concise string representation. So let's start here. Let's grab, we're going to pass this program a message, and we'll stick in a variable called message, and we'll say, give me the first argument, pass to this program. And then let's, we'll do a lot in this one line here, but let's create a variable called string64. This is going to be a Base64 representation of the hash of that message. So bear with me here. This is going to be kind of a long line. So we'll say encode whatever comes next in base64. And what comes next is the hash, the SHA-256 hash, to be more precise, of the message. Make sure I have my parentheses right. I think that's right. And then let's just print it out. So print message is message. Print SHA is that string 64. And I think that's good. So let's try running it. Say Python proof of work 1, and then we'll just pass it some message. This is a message. So we have the message, and then we have the base64 SHA-256 output. This at the very end, this is actually not part of the base64 encoding, that equal sign. That just gets into something called how it does the block ciphering, and that's kind of a pad at the end. But the normal characters that are in the base64 are all the letters, uppercase and lowercase, numbers, and the plus sign. There might be a couple other symbols too, but it's mainly just numbers and letters. So good. So now if we pass in a different message, this is a different message. As you'd expect, we get a different hash. But you can see the length is always sort of the same of the hash. And just by slightly changing the message, we get a drastically different hash. Not even close, even though the letter or the message is just one letter different. So good. That is part 1. So why don't you guys sort of reproduce what I've done here, and that will get us on our way to building a quick proof of work sort of product here.